Good afternoon from sunny Florida. This is Kevin Songer, and today we're going to discuss the complex challenge of designing coastal green roofs using native plant species. For years, we here at Metro Verde have worked with Florida green roofs and green roofs along the coastline. We've worked with green roofs on sloped applications using a variety of geosynthetic materials and green roofs that were based around very lightweight components. Although native plants are our favorite species to work with, we've also worked with a number of grasses and other landscape species on green roofs here in Florida. One of our biggest challenges in designing coastal green roofs was adapting to historic structures while maintaining structural integrity with respect to cyclones, tropical storms, and hurricanes. We've worked closely with the University of Florida Civil Engineering Department and their outdoor hurricane wind simulator testing green roofs in excess of 130-mile-an-hour tropical storm wind speeds. One of our more recent and interesting coastal green roof projects was on the island of Bermuda, right down Hurricane Alley, for a military hospital. We believe that green roofs have a positive impact on economy, ecology, and the community fabric. Though influenced by many harsh environmental factors, coastal green roofs can produce successful landscapes or highly productive food systems. One of our favorite types of projects is designing coastal green roofs using native plant species. Designing a coastal green roof doesn't have to be hard. In fact, it can be fun. Interestingly though, one of the first questions I always hear is, why use native plants on a coastal green roof to begin with? I always tell clients the decision to use native plants on a coastal green roof is a personal decision. Some of the benefits include long-term survivability, creation of wildlife habitat, beauty, and the opportunity to educate our young people. So in today's video, we're going to discuss our design approach, looking at plant selection, the different types of photosynthesis, CAM, C3 and C4, root architecture, design layout, modeling, and a number of factors that go into choosing the right plants for the right place on the roof and ensuring a coastal green roof that will look good years after it's first installed. One very important note here is that although we present a unique approach to design, always consider ANSI, ASTM, and FLL standards. So why design a coastal green roof using native plants? Why not use turf or landscape plants? Both turf and landscape plants are very valid approaches to designing and implementing a coastal green roof. However, native plants on coastal green roofs are a personal decision, creating a very unique work of bioart. It's a niche, a potentially confusing niche, beginning with the question, what actually is a native plant? As you will find out, there are many definitions to the question of what is a native plant. The US FHWA defines native plants as those plants being endemic to an area or naturalized over geologic time. But what about man's influence on where plants are located? Be careful, there are too many different answers to the native plant question. It's easy to get lost in semantics and miss the green roof design. So what do you do if your project specs require native plants? Well, on our Bermuda project, first place we started was with the literature. Fortunately for our Bermuda project, we found several good books from the 1800s about native plants and the island. One important note to consider is that after value engineering, native plants, which can be very expensive, are often eliminated from a project. However, with an in-depth understanding of the ecology of the project site and a little bit of digging into where your local native nurseries are located, the use of local and endemic native plants can actually benefit the long-term success of a coastal green roof. However, with scant literature concerning coastal green roof design and native plants, we have found that long-term study of the site produces good results. Understanding your project site's native botany is an important prerequisite to a successful green roof design. One of the best ways to determine what plants will do best on your green roof is to take what I call ginkgo walks. Ginkgo walks is a haiku term loosely defined as that of understanding your surroundings. And so for an upcoming coastal green roof project, we've studied the site for a year, starting with the structure or evergreen plants growing locally. One of our first objectives that we want to produce from our ginkgo walks is the development of a bloom chart or bloom rows. So let's take a look at the wide variety of native plants growing locally around our project site and see which of those we would like to incorporate into our design. One of the first structure plants that we see growing across the dunes where our green roof is to be located is Adam's needle, or Yucca filamentosa. This is a marvelous drought-tolerant plant that provides wonderful habitat and evergreen structure to a green roof. Prickly pear, or Opuntia cactus, is another great drought-tolerant native plant to consider using in your coastal green roof design. Opuntia's leaf pads and bright red fruits are important food products also. With its deep dark green color, Florida's native Coontie, or Zamia, is a great salt-tolerant plant perfect for coastal green roofs. The Coontie life cycle begins with an interesting cylindrical brown sprout. Cockspur is another Opuntia species that is well suited for coastal green roofs. Cockspur is very salt tolerant and drought resilient. Be sure, however, to watch where you walk around cockspur as the needles are deadly. Resurrection fern is an amazing plant, one of those species that has always fascinated me. Resurrection fern is a salt-tolerant, evergreen structure plant that grows well and can be used successfully on coastal green roofs. Another of the structure plants that we find growing well across the site is sea oats. Sea oats is a marvelous structure plant, member of the Poaceae family, and can provide important windbreak functions around our more tender green roof plants. Hydrocotyle or dollarwort is the bane of many gardeners. However, it is a very important plant with respect to removing nutrients such as nitrogen and phosphorus from stormwater and can be a valuable evergreen addition as it's salt tolerant on our coastal green roof design. Native grasses, because of their C4 photosynthesis, provide a very important windbreak component to your coastal green roof. Identifying your site's native grasses will provide you with many options. Broom sedge, or andropogon, is a beautiful Florida native grass with brilliant blue hues in the late summer and stunning brown color in the fall. Salt and drought tolerant broom sedge will make a good perimeter and windbreak plant. Our ginkgo walks and site botanical investigation has showed us also that seashore paspalum is present in large amounts and should do very well on the green roof. Paspalum can be used in the coastal green roof design to provide windbreaks for more tender plants. You will find the native grasses growing across your project site will provide important structural components to your coastal green roof. Dwarf Yucca holly, or Ilex vomitoria, has red berries that are sought after by many birds, provides habitat, is salt tolerant as well as drought tolerant. Yucca holly makes another good structure plant for your coastal green roof design. Along with Yucca, the American holly is another evergreen, salt tolerant, and well suited for green roofs, especially those areas where some height is desired. Shiny blueberry, a vaccinium or member of the blueberry family, is often found growing along dunes and another good evergreen structure plant. Though it does not produce large amounts of fruit, shiny blueberry has beautiful, tiny spring flowers. Catbrier or Smilax is another evergreen structure plant often found growing on coastal dunes and suitable as a structural component in your green roof. In addition to its edible tips, Catbrier or Smilax is also a very important butterfly plant. Finally, wax myrtle is also evergreen and often found growing across many coastal dunes. Wax myrtle, too, like American holly, makes an excellent green roof structure plant. Importantly, the dozen or so evergreen structure plants we've identified will give us green color throughout the year. However, flowering plants will give us a variety of hues at different times of the year. One of the first flowering plants to be seen in the springtime here along the coast is Innocence. Innocence is a creeping ground cover with beautiful white blossoms that appear during January and February. When Innocence is blooming, one can be sure spring is just around the corner. Sometimes your ginkgo walks will turn up unexpected delights. Beach verbena is an endemic species native to Florida and very rare. This evergreen plant will provide beautiful purple color to your coastal green roof in the dead of winter when very few other flowers are blooming. Salt tolerant and drought tolerant, verbena is an excellent plant design choice. Another purple plant for your coastal green roof is the thistle. The purple thistle is a very important food source to butterflies. Drought and salt tolerant, this plant makes an excellent coastal green roof addition. Spiderwort is another one of the coastal plants that provides beautiful color from the earliest of spring to the late days of summer. An important pollinator plant, spiderwort is also extremely drought and salt tolerant. Wild poinsettia can be seen growing across many dunes at the beach. Wild poinsettia's orange hues provides interesting contrast to the color palette of a coastal green roof. A very hardy and salt-tolerant plant suited well for coastal green roofs is the coral bean. Coral bean provides amazing, brilliant red spring flowers. This plant species grows reliably where salt spray is the most intense. A marvelous addition to any coastal green roof is the evergreen coral honeysuckle vine. Coral honeysuckle is an important nectar plant for hummingbirds. This species not only provides year-round structure, but also beautiful spring color. Another evergreen vine great for coastal green roofs is the Carolina jessamine. In addition to the green structure, Carolina jessamine provides brilliant yellow, a great contrast to the purple and red spring wildflowers. Carolina jessamine is beloved by bees. Gaillardia is probably one of my favorite coastal green roof plants. Also known as blanket flower, Gaillardia blooms year-round. Gaillardia will typically die back during the winter, but reseeds itself prolifically. This plant is a very important coastal pollinating plant. Without a doubt, Gaillardia or blanket flower should always be considered as a primary green roof plant along coastal areas. Gaillardia, along with Dune Sunflower, are members of the aster family. Most asters have C4 photosynthesis capabilities, making them extremely drought tolerant. Dune Sunflower, or Helianthus debilis, goes hand in hand with Gaillardia as being one of the most important plants for coastal green roofs. Our ginkgo walks show us that Dune Sunflower grows everywhere, year-round, blooming in the heat of summer or the dead cold of winter. Both Dune Sunflower and Biden's alba Spanish needles will either prolifically reseed or grow out from their roots if bitten back during the winter. Spanish needles is both drought tolerant and salt tolerant. I am always amazed at the quantity of honeybees that are attracted to Biden's alba or Spanish needles. Though some consider Biden's alba to be a weed, I would always consider her to be a prime candidate for a coastal green roof design. Slender Goldenrod is one of those amazing plants that you discover when walking across the dunes. Well suited for coastal green roofs, Slender Goldenrod attracts many pollinators and has an amazing scent. Her bright yellow flowers provide brilliant spring color. Camphorweed is a beautiful low-growing member of the aster family. Camphorweed's name is derived because when the leaves are crushed, they emit a strong aromatic odor. Salt and drought-tolerant camphorweed is an excellent choice for coastal green roofs. Another favorite plant of mine for coastal green roof design is Passiflora or maypop. Passiflora is a deciduous vine that produces beautiful late spring and early summer flowers. Horseminta or Monarda is yet another great coastal strand plant suitable for salt-impacted green roofs. This plant is very drought tolerant and a great pollinator species. Some coastal strand or dune plants, such as the oxeye daisy, appear to do well with respect to salt tolerance. However, oxeye daisy requires moist soils. It is important to be able to differentiate on your ginkgo walks or site botany surveys between those dune plants that are drought tolerant and those like oxeye daisy or elderberry that can require significant amounts of water and moist soils. There are a number of different Tillandsia species and epiphyte that grow well along the coastal strand and up in the dunes. Tillandsia can make an interesting addition to coastal green roofs. Your weekly botanical forays across the project site will undoubtedly turn up a lot of incidences of goldenrod. Solidago or goldenrod is a great coastal plant, drought tolerant and salt tolerant, perfectly suited for green roofs. Goldenrod provides interesting summer color and is also an important nectar plant for pollinators. Numerous morning glory species grow abundantly across the dunes and within the coastal strand and make perfect flowering plants for green roofs. Purple flowering railroad vine is an excellent addition to any coastal green roof planting design. Yet another interesting flowering beach vine is the beach morning glory. With brilliant white flowers, this plant is a stunning addition to coastal green roofs. Drought tolerant and salt tolerant, this plant will grow well across any given roof exposure expanse. One of the rarer and more interesting beachfront vines is the little seen Seaside Bean. Seaside Bean will grow right in the sandy dunes, is evergreen, and offers stunning summer fuchsia color-like blooms. Finally, the ocean blue morning glory rounds out the morning glory vines that are typically seen growing in the dunes. This plant, in addition to the other morning glory vines, makes a great green roof addition. Our native Ruellia, not to be confused with the invasive landscape Ruellia grows great across salt-impacted shady areas. This plant should also be considered as a prime green roof plant candidate. One of the asters you can always count on to find blooming during the summer, besides Gaillardia and Dune Daisy, is Pityopsis graminifolia, or silkgrass. Here in Florida, silkgrass blooms prolifically during the summer. Silkgrass has always been one of the favorite feeding places for our native bees and butterflies. As a C4 plant, silkgrass is highly drought tolerant. Another of my favorite plants for coastal green roofs is the turkey-tangled frog fruit. Phyllonata flora is both a salt-tolerant and drought-tolerant ground cover, well suited for coastal green roof applications. Although rarely found growing in the dunes, the Glades Morning Glory is extremely salt-tolerant and usually inhabits coastal and salt marsh areas. Though weedy in growth habit, Glades Morning Glory is always a reliable coastal green roof plant selection. Yet another salt-tolerant species is frostweed. This plant flowers late into the summer, hence its name, typically seen blooming until first frost. Polygala, or procession flower, is another very interesting addition to a coastal green roof, and grows well with respect to drought and is extremely salt tolerant. Some of the more brilliant late summer blooming flowers like Carphephorous and Liatris are also salt and drought tolerant, grow amongst the dunes and in the coastal strand, provide plenty of color for the coastal green roof during the late summer season. Salt and pepper plant is yet another very interesting plant growing in the coastal strand and along the shady dune areas. Wood germander, although somewhat of a weedy plant, has a brilliant display of late summer, early fall flowers, providing pollen and nectar to numerous insects, butterflies, and bees. The legumes are a very important coastal strand and seashore plant family, fixing nitrogen, growing well with respect to drought, and very salt tolerant. In fact, some of the legumes, such as the thicket bean, are an important food source historically. A deciduous vine, thicket bean, will provide interesting texture and color to a coastal green roof during the late spring and early summer. Yellow leaf cup is a salt and drought tolerant aster species suitable for coastal green roofs, one preferring a little bit of shade. Of course, the golden asters are very hardy, extremely drought tolerant, and very well suited for coastal green roof plant applications. I think the golden asters produce some of the most brilliant and stunning arrays of flowers found anywhere along the coast. Salt marsh aster that are growing in our project area is one of those plants requiring moist soils. Poor man's patches, however, grows across the dunes and throughout the coastal strand, is extremely drought and salt tolerant, and provides amazing late summer color. Betony is considered to be a weed by many. However, Betony has proven herself throughout the winter to provide evergreen cover and to provide brilliant displays of light purple flowers. Garbaria heterophylla is one of those unexpected surprises that one occasionally sees growing across the coastal strand or dune area. This plant is also very drought tolerant, salt tolerant, and well suited to coastal green roof applications. Believe it or not, common dog fennel has some of the most glorious late summer, early fall white blooms found along the dune area. A hardy plant, dog fennel should be considered in any coastal green roof application. Asclepiases, or the milkweeds, are yet another drought and salt tolerant flowering plant that can be found growing on our project site in the coastal strand and along the dunes. There are many different types of milkweeds, and one of my favorites is the butterfly weed Asclepias tuberosa. All of the milkweeds provide important wildlife function. You won't find another plant capable of attracting butterflies en masse than saltbush. Saltbush is an interesting structure plant that is deciduous, yet should be considered on just about any coastal green roof application planting scheme. Southern Gara is a diminutive yet very salt and drought tolerant, colorful plant that can be used and interspersed amongst other plants on the coastal green roof. Pokeweed is one of those plants that you either love or hate. Undoubtedly, this plant has brilliant displays of bright pink and purple color with broad green leaves and grows well in dune conditions. All Coreopsis species are considered the flower of the state of Florida and great green roof plants. Ageratina is another one of those smaller plants, but important in the coastal strand and applicable for green roof design. One of my favorite late summer and early winter plants is the climbing asters. These plants produce copious amounts of flowers and are extremely reliable to bloom year after year. Very drought tolerant, they do like moist soils. Yet climbing aster will do well in dry areas. Climbing aster can be planted on green roofs around air conditioning condensate drains. Hypericum species are common evergreen flowering plants found in the coastal strand and growing along dunes, and are perfect plants for coastal green roofs. Another extremely fascinating plant found growing in the coastal strand and applicable for coastal green roofs is honeycomb head, a member of the aster family. With C4 photosynthesis capabilities, this plant is extremely drought tolerant and provides a good windbreak. Sandweed, again, is a Hypericum, an evergreen species, and does well on green roofs along the coast. Echinacea, or coneflower, is another C4 species, member of the aster family, that makes a good windbreak hedge and is very salt and drought tolerant. Dewberry is an interesting addition to any coastal green roof. This plant species is quite salt tolerant, very drought tolerant, and provides food to a variety of different wildlife types. One of the first plants I ever used on coastal green roofs was the leerleaf sage. The leaves are typically evergreen, and the plant offers beautiful springtime lavender colored flowers, a great addition to any coastal green roof planting scheme. C. purslane is also extremely drought tolerant, one of the first plants found along the shoreline growing atop dunes. Very salt tolerant, very drought tolerant, and interesting coastal green roof plant. Once you've completed a full annual cycle of ginkgo walks or site biological botanical assessments, then you can start developing your plant list and your plant bloom rows. This site plant bloom rows is important to coastal green roof design because it allows the designer an insight into what color schemes are available throughout the different seasons of the year. So by tracking what plants are blooming when throughout the different months of the year and the color of those blooms, the color rows can be created. And not only is it beneficial to the green roof designer, but also to the client in visualizing what types of colors the green roof will offer during the various seasons. Now let's review a little bit of fundamental botany relevant to coastal green roofs. There are basically three types of photosynthetic processes: C3, C4, and CAM. First, let's take a look at C3 photosynthetic processes. In C3 plants, photosynthesis occurs very near the leaf's surface in chloroplasts. In C3 plants, photosynthesis occurs rapidly, uses a lot of water, and is extremely subject to quick desiccation. C3 plants grow fast. However, C3 plants can quickly be desiccated by strong winds or overbearing sunlight and can keel over and die. C3 plants do best where there are high levels of carbon dioxide, such as urban areas. And on a green roof, C3 plants are important because they provide plenty of cover quickly, yet they must also be protected from the elements and are therefore usually found in a more protected zone on the roof. Unlike C3 plants, C4 plants are more drought tolerant. C4 plants break the photosynthetic process down spatially into two separate areas, one embedded deeply in the leaf to protect the sugars and the chemicals from rapid water desiccation through winds and extreme heat. Some of the best known C4 plants include the Poaceae, the grasses, and the aster family. Because photosynthesis is embedded in the plant and protected from desiccation, C4 plants are more drought tolerant and can be used as windbreaks on a green roof. C4 plants play a very important role in our world's ecosystem. Unfortunately, as carbon dioxide levels increase, pollution and smog have detrimental effects on C4 plants. C4 plants can be seen growing where C3 plants will not grow due to overly desiccating winds and other limiting environmental factors. Coastal dune areas buffeted by desiccating winds show C4 plants' abilities to survive in areas that C3 plants would not survive in. C4 plants make great windbreaks for green roofs. In addition to the Asteraceae and grass family, there are other C4 plants. Understanding C4 photosynthesis is critical to good coastal green roof design. The third type of photosynthesis found in plants is called CAM. CAM, or CAM, stands for crassulacean acid metabolism. A CAM plant differs from C3 and C4 photosynthesis by closing their stomata during the day when water desiccation could occur and opening the stomata only at night. CAM plants isolate photosynthesis on a temporal basis rather than a spatial basis as in C4 metabolisms. The importance of CAM metabolism is that by stomata remaining closed during the day, plants can survive for extremely long periods of time without water. Cam plants typically include many of the cactus, agave, yucca, bromeliads, and orchids. Cam plants make excellent primary perimeter windbreaks for green roofs. Understanding the relationship of C3, C4, and cam photosynthesis is an important aspect of coastal green roof design. Now, let's take a look at a coastal green roof design model that we utilize on a frequent basis. Organizing data used as a basis for making green roof design decisions is very important. Initially, on our model, we will take a look at generic project information, including name, contact information, addresses, etc. It is important to identify and document the existing land use categories on a site. Additionally, it's just as important to quantify and identify all of the native species that grow well on a project site. Early on in the model, we list all the plants that we find on site based on our ginkgo walks and botanical surveys. Using the genus and species information we've gathered during our ginkgo walks over the course of a year, we can formulate a site flower bloom rose. The site flower bloom rose provides us with an annual look at plant activity. Importantly, the three primary design variables that we will work with on coastal green roofs are salt scorch, wind effects, and light availability. The coastal green roof model requires that one break a roof section down into a grid. Within the grid, each polygon relates to the intensity of wind impacts, the availability of light, and the intensity of salt scorching potential. To most, sunlight availability is obviously an important design principle, but let's look closer at what wind can do and how it can impact green roofs. Sometimes I consider wind to be a hidden impact for green roofs. Barely noticeable breezes of 2 to 3 meters per second can quickly desiccate or overcome the vascular system of a green roof planting and cause injury to the plants. It is crucial for the green roof plant designer to understand project site wind profiles. Oftentimes, to the casual observer, it will appear as though there are very few winds buffeting a project site, when in fact, as we have here in the video, there are winds in excess of 3 meters per second. A 3 meter per second wind can quickly overcome a plant's vascular system. If you don't have an anemometer, no problem. You can go to NOAA's website and other great climatic information websites that provide wind details for cities across the United States and across the world. In addition to desiccating effects, winds can actually affect root architecture and the structure of the plants. One of the reasons that we work with three-dimensional matrices on coastal green roofs is the ability for plant roots to grow out and anchor themselves to the web of material. Typically on a coastal green roof, a three-dimensional web that's permanently anchored to the structure provides a platform for plants to anchor themselves to. Parapets are the best structural answer to windbreaks on a coastal green roof. However, where parapets are unavailable or the green roof is sloped, then the use of CAM or C4 plants may be substituted, these plants adequately breaking wind across a green roof. Understanding both light availability and wind direction across a coastal green roof is an important component of a successful green roof planting model. Transposing wind directional data and light availability onto the roof grid allows the designer to identify areas that may be problematic with respect to C3 plant placement, and instead the designer may use a C4 or CAM plant as a windbreak. Salt impacts can be hazardous to plants. There are many salt-tolerant plant charts available on the web. However, the very best method of determining the severity of salt spray is through field excursions, the ginkgo walks, and botanical surveys. These photographs illustrate how salt spray can damage a plant. Notice the salt spray damage occurs on the windward side of the plant. Halophytes, or salt-tolerant plants, such as some of the seashore grasses, can serve as both wind breaks and salt breaks. Although there are, again, many web resources that define what plants are best suited for salt-impacted environments, we found that the ginkgo walks and site reconnaissance will ultimately reveal more important information for the green roof design. There are also a handful of other important design factors we call secondary design factors that impact the layout of a coastal green roof. One, for instance, relates to plants. During our ginkgo walks and botanical survey, we identified many plants that do grow very well in the coastal strand and up in the dunes. However, hidden amongst these plants sometimes are important hydrological factors such as groundwater levels. Some plants may appear to be drought tolerant yet require quite moist soils. Just because a plant grows in a dune does not mean that it is necessarily drought tolerant. Many times plant root architecture will extend deep into the soil media in an attempt to find water. And some of these plants, such as the oxeye daisy, are very dependent on a high water table or moist soils and may not do well on the green roof. Some coreopsis, such as the Coreopsis leavenworthii, also require a level of moist soils. During one rather large recent coastal green roof design, the landscaper wanted to use the oxeye daisy, thinking that it was very drought tolerant because it grew on the dunes, not knowing that it's listed as a FACWET or obligate plant by the U.S. Army Corps of Engineers. Same way with elderberry. Allelopathic influences can also greatly impact a coastal green roof. It's important to consider what plants are growing around your proposed roof platform. Within the coastal dune ecosystem, there are some tree species that possess leaf litter which can be toxic to emerging green roof plants. Plants such as pine trees drop smothering pine needles, cypress needles have very allelopathic toxic effects, and it's important for the green roof designer to identify adjacent trees and those species that may impede green roof growth. The coastal green roof project designer can then take information pertaining to incompatible species and design the roof layout accordingly. The more pertinent information that can be overlaid on the site layout grid for the coastal green roof, the better chances are for the designer to develop a green roof planting scheme that will be successful in the long run. There are, in reality, many secondary design variables that can impact a coastal green roof. It's up to the designer to analyze each particular site and develop a list of potential impacts. Sand deposition is a very real potential for coastal green roofs. In addition to salt scourge, wind, and light availability, sand can completely cover a green roof within a matter of weeks. Sand, however, contains many micronutrients, and I always like to add a little bit to the soil media. But sand is unpredictable. You can never block in or block out sand. Sand has a mind of its own, and combined with strong coastal winds, sand can have a definite positive or negative impact on coastal green roofs. Combining all the primary and secondary design variables that the green roof designer has assimilated during site observation, the green roof designer can now come one step closer towards finalizing a successful green roof planting design. Take the plant species list developed from the ginkgo tours and site botanical surveys. Divide the existing native plants found growing on site into C3 plants, C4 plants, and CAM plants, respectively. CAM plants should always be used as perimeter plants on the coastal green roof. C4 plants such as the Asteraceae and the Poaceae, the asters and the grasses, can be interwoven with the CAM plants to serve as perimeter wind and salt breaks, and they can be used as an interior windbreak to protect more sensitive C3 plants. A coastal green roof designer should quickly be able to look at a project site and read nature's patterns. CAM and C4 plants, such as the seashore grasses, will be growing in those areas that C3 plants cannot adapt to. Seashore grasses, because of their C4 photosynthesis, are especially well adapted to frontline wind exposure. Variations in elevation across a site can easily be recognized by the difference in plant biology, responding to different wind impact levels. A green roof designer will recognize the fact that more tender C3 plants are protected and surrounded in nature by C4 and CAM plants. For the successful coastal green roof, the green roof designer must be able to look at a site and differentiate between light availability, wind impacts, and salt scorching potential. Another very important note for the coastal green roof designer is to always follow ASTM and other fire standards. Finally, a coastal green roof with all the challenges can be a very unique work of art, a beautiful masterpiece. The tools are in the hands of the green roof designer. Understand the site, understand the plants, understand the environmental variables, and you're sure to create a long-lasting, successful coastal green roof with native plants.